This is John Lineval, and this is how to study for SAT and ACT imaginary numbers. Here's my contact information if you'd like to contact me, and don't worry, you'll see it again at the end. Please remember to like and subscribe if you like this video. Please click the notification bell in the upper right-hand corner, and thanks very much. What we're covering here: what's an imaginary number? Why does it matter? What's a complex number or a complex conjugate? Why do I need to know about imaginary numbers for the SAT or ACT? If you like this video, please don't forget to give this a thumbs up, subscribe to my channel, and click in the little bell in the right top corner for notifications. So, what's an imaginary number? Well, you might be wondering, how the heck can a number be imaginary? Well, an imaginary number is defined as anything that's a multiple of the square root of -1. How's that imaginary, you ask? Simple. 1 times 1 is 1. 1 times -1 rather, -1 times -1 is 1. So there's no number you can multiply by itself to get -1. That is, there's no square root of -1. So the square root of any negative number is just the square root of the positive number multiplied by the square root of -1, also known as I, or the imaginary unit. Why? Because the square root of AB is equal to the square root of A times the square root of B. The same rules of math apply to imaginary numbers as real numbers. Why does it matter? Well, for some quadratic equations, there are only imaginary solutions. If the discriminant in the quadratic formula b squared minus 4ac is less than 0, the solutions are imaginary. The quadratic equation has no x-intercepts if it has no real solutions, and vice versa. So you can see here we have a graph of a quadratic equation that has no solutions because it doesn't cross the x-axis. So, if b squared minus 4ac is a negative value, the equation has complex conjugate roots. That is, the roots containing i's, and I'll explain what a complex conjugate is next. Also, here is the quadratic formula in case you've forgotten it. You have to set ax squared plus bx plus c is equal to 0, and x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So what's a complex number or a complex conjugate? A complex number is a number of the form a plus bi, where a and b are real numbers and I is the imaginary unit. So all complex numbers are a real number plus an imaginary number, including 0i. So the imaginary unit would be multiplied by 0, which means the result would just be a real number. That means that all real numbers can be expressed as complex, such as 3 could be 3 plus 0 times I. And this is my one good math joke. Numbers are like relationships. If you say they're complex, you mean they're part imaginary. All right. So what's a complex number or a complex conjugate? Well, complex conjugates are numbers in the form a plus bi and a minus bi, where a and b are real and I is the imaginary unit. So a plus bi is the complex conjugate of a minus bi and vice versa. So they're both complex conjugates. Complex conjugates are kind of the inverse, bizarro version of the difference of squares. So instead of a plus b times a minus b equals a squared minus b squared, the difference of squares that you see all the time on the SAT, we have a plus bi times a minus bi is equal to a squared plus b squared. Because remember, you have bi squared. I squared is just -1, so it'd be a squared minus b squared I squared, which would just be a squared plus b squared, because I squared is equal to -1. Okay. What do I need to know about imaginary numbers for the SAT or ACT? You have to know how to add, subtract, multiply, and divide complex numbers. You also have to understand the powers of the imaginary unit, I, and how they repeat. That's about it. It's pretty easy. Adding and subtracting complex numbers. Complex numbers are like any other binomials. To add and subtract them, treat them like any other binomials and combine like terms. So for example, we have 5 plus 3i plus 4 plus 4i. So then you just take the 5 and add it to the 4. And you take the 3i and the 4i and add them together. So you get 5 plus 4 is 9, and 3i plus 4i is 7i. And if we're subtracting, you can have 5 plus 3i minus 4 plus 4i. So the first thing you do is take the negative sign and just take everything inside these parentheses and multiply it by -1. So you get minus 4 and minus 4i. So then it's going to be 5 minus 4 plus 3i minus 4i, which is 1 minus i. And we have another problem here where you have 2 minus 3i plus negative 4 minus 5i. So it's 2 plus negative 4, which is going to be negative 2. And then you have minus 3i plus 5i, so that's going to be 2i. So you end up with negative 2 plus 2i. Okay. All right, as I said, complex numbers are like any other binomials. So if you want to multiply complex numbers, you just treat them like any other binomials and you use the FOIL method. So you multiply the first terms, so here we have first, and then you multiply the outer terms like this, a times d, and then you multiply the inner terms, b times c, and then you multiply the last times each other, b times d. So, for example, if we have 5 plus 3i times 4 plus 4i, the first terms are 5 times 4, so we get 20. The outer terms are 5 times 4i, which is 20i. The inner terms are 3i times 4, which is 12i, and the last terms are 3i times 4i, which is 12i squared. Of course, then you end up with 12i squared is the same as minus 12 because I squared is equal to negative 1. So 20 minus 12 is equal to 8. And then 20i plus 12i is 32i, so we just end up with 8 plus 32i. The problem we have here, same thing. 3 minus 4i times 4 plus 5i, 3 times 4 is 12. 3 times 5i is 15i. Inner 4i, negative 4i times 4 is negative 16i. And then 4i times 5i, okay, you end up with minus 20i. So then minus 20i squared, since I squared is equal to negative 1, you end up with negative 20 times negative 1. So then it becomes 12 minus I, because it's 15i minus 16i, plus 20. So you end up with 32 minus I. So again, 3 times 4 is 12. 3 times 5i is 15i. Negative 4i times 4 is negative 16i. So these just become 1i. This becomes 12. Negative 4i times 5i becomes negative 20 times I squared, which becomes negative 20 times negative 1, which becomes 12 minus I plus 20, which becomes 32 minus I. Dividing complex numbers, well, that's a little more complex, if you'll excuse the pun.
A little more complicated than that.
Oh, okay. Well, I didn't realize that it was complicated. In that case, all is forgiven.
Let's take an example. 3 plus 4i divided by 5 plus 2i. The first thing you want to do is write it as a fraction. That is, don't use this little division symbol that, especially when you get a little older and your eyesight's not so good, looks like a plus sign. And you write it as a fraction. So 3 plus 4i over 5 plus 2i. Then you multiply the top and the bottom, that is the numerator and the denominator, by the complex conjugate of the bottom, that is the denominator. So the complex conjugate of 5 plus 2i is 5 minus 2i. And since 5 minus 2i divided by 5 minus 2i is 1, we're not changing the actual value, but we're making it a more useful form. So, okay, 3 times 5 is 15. 3 times minus 2i is minus 6i. 4i times 5 is 20i, so that becomes 14i. Then 4 times negative 2i becomes negative 8i squared, so I squared is equal to 1. So that becomes plus 8. So we have 15 plus 8, and we have 14i, because it's negative 6 plus 20i. So then you end up with 23 plus 14i, because 15 plus 8 is 23. And then we have on the bottom, because of the difference of squares with the complex conjugate, it becomes 25 minus 4i squared, which becomes 25 plus 4, because I squared is negative 1, so minus 4 times negative 1 is just going to be 4. So we end up with 23 over 29 plus 23 plus 14i over 29, which you can split into a plus bi form to get 23 over 29. That would be a. And then b would be 14 over 29 times I. So that's how you divide complex numbers. That's how you should do it on the SAT. A lot of times they're going to ask you a question like, what is the value of a plus b, or what is a times b, or a over b? So be prepared to answer that. In this case, it was a plus b, then it'd be 23 plus 14, which would be 37 over 29. But here we're just solving the problem. So that's something you should look for on the test. The powers of I. Now, this is something you need to know for the SAT and possibly the ACT, although, in my opinion, it doesn't really show much more than that you've just memorized a trick. It's kind of the intellectual equivalent of the ice bucket challenge, or way back in the 1930s or so, on college campuses, it was really popular to swallow goldfish. It's not quite as stupid as the Tide Pod challenge, but I don't think it really shows anything other than you just memorized a trick. Anyway, you need to know it for the SAT, so just know it. I to the first power is just I, like anything else to the first power. I squared is -1. I cubed is -I. I to the fourth is 1. So I to the fifth is just I. So this repeats every 4 iterations. In other words, I squared is the same as I to the 6, because 2 plus 4 is 6, equal to -1. So you'll probably see this as something like, what is the value of I to the 2019th power? If you try plugging this into your calculator, you're not going to get anything useful. So what you can do, though, is divide 2019 by 4 and take the remainder. Now with a calculator, what you can do is type in 2019, divide by 4, and you get 504.75. So you might be saying, well, John, how does that help? I don't see a remainder. It's easy. If your calculator doesn't do remainders, like this one doesn't do remainders, then you just subtract the whole number. So you take out the 504. And you're left with 0.75, and then you just multiply it by what you were dividing by. So multiply that by 4. Boom, your remainder is 3. Don't believe me? We can easily check it. We can just go 504 times 3 is, oops, wait a minute, made a mistake. It's 504 times 4, because we were dividing by 4. Don't get 2016, and so we can just subtract 2019, get -3, multiply that, make it positive. It's just going to be 3. So that is 3. All right, and that's a little cat in the background there. All right, so I to the 2019 is equal to I cubed, which is -I. And all right, did you find this video useful? Well, if you did, please like it and subscribe to this channel. Neither action costs you anything, and you'll be alerted about my new and always free videos. Why do I care? Well, YouTube doesn't give me any ad revenue unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes of view time in a year. So if you saw an ad on my channel, please know that I got nothing from it. And while many people are watching these, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers, although I've been getting lots more recently, so thank you very much. And for the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos, and I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or things that are off topic, spammers and disturb people. So again, thanks for watching. And again, contact me. If you want to contact me on Facebook, you can go to facebook.com/Linneball Tutoring.
You been stalking my Facebook?
I look like I'm on Facebook.
Excuse me. You can contact me or see things on Instagram. Just go to instagram.com/john.linneball.tutoring. My phone number is 415-986-7355. It's 415-986-7355. You can email me at john@johnlinneball.com, and you can visit my website at www.johnlinneball.com. All right, hope this helps.